Hi, I'm very short content, and this is my Physics 2212 Lab 4 report. So the purpose of the lab was to predict the behavior of circuits containing resistors in series and parallel, and then use multimeters to measure the actual values of conventional current and potential differences in the circuits, and examine the behavior of ohmic resistors and capacitors. So the system and the surroundings were the system was the circuit battery and the ammeter. The surroundings were everything else. And for the preview of the results, the capacitor stopped the current once fully charged, and the capacitor's current is at a max at the instant it starts discharging. The round trip sum for our circuit was 0.02 amps, although it should have been 0, and the capacitor charge and discharge times were 14.35 and 16.7 seconds respectively. An error could be that due to incorrect measurements, math, or bad equipment, our results could have been affected. So some of the models and equations is Kirchhoff's closed loop law that the potential difference for a round trip path is 0, and it follows the conservation of energy, and that delta V round trip is equal to 0. For Kirchhoff's junction law, we have the current entering the junction is equal to the sum of the currents from each junction, and it follows the conservation of charge, where I in is equal to I out. And the resistance, we have both in parallel and in series, and all of these equations are shown here. So for our circuit in series, for the setup, we have two 1.5 volt batteries and two resistors, one at 100 and one at 47 ohms, and one multimeter. For the data that we collected, we got a current of 0.02 amps, and the current in reverse would be the negative of that, and the voltmeter was 3 volts. So the data that we have for the in-series circuit is shown here. As you can see, the total round trip was not 0, which is not supposed to happen. So for explanation, we have the voltage would drop every time it passes through a resistor, because that's what resistors do. From B to C, the voltage changed a little bit, meaning there was a slight resistance in the wire. Passing from A to B gave us 2.9 volts because the battery provides about 3 volts to the circuit, and the net voltage is roughly 0. It may have been slightly above 0 due to error or outside forces, and the ammeter doesn't change because the current doesn't run through the voltmeter. So for our graph, as you can see, there's a slight increase, and then it plateaus, and then when it hits a resistor, it decreases. And the current decreases, and then it decreases once more until it's 0. So for the setup, for the RC circuit, in parallel, we have two 1.5 volt batteries, two 10 ohm light bulbs, and one 200 MF capacitor. And for the data collection, when all are in series, the light shined brightly before getting dim and turned off, which took about 14.35 seconds. And then without the battery, the light shined brightly before it turned off, which took roughly 16.7 seconds. So for the current, when initially uncharged and attached with the battery, the current will be at its maximum. Then it reaches 0 amps when the capacitor fully charges. Once fully charged, the battery can then be removed from the circuit, and the capacitor will start discharging, producing the maximum current in the circuit before reaching 0 amps when fully discharged. So for the what if questions, I have, what if you were doing this lab in real life and used an actual ammeter? We did do this lab in real life, which is why our information might not be as accurate as if we did online. The online ammeter would have most likely shown a 0 total round trip voltage, whereas ours showed a 0.02 round trip voltage or current, and our ammeter showed some resistance while the online one did not. And what if we use an ammeter to measure how long it takes to charge the capacitor and compared it to the predicted time? Theoretically, the capacitor should be able to just charge instantly in a perfect scenario with 0 resistance. However, the resistance in the wires and resistors will slow down the charging of the capacitors. Thank you so much for watching, and hope you liked it.